Okay, so in this lesson we're going to review some basic solving equation processes. So these are called linear equations because they will all have one variable in them to the exponent of 1. So most basically, let's review solving two-step equations. When we're solving all equations, we need to make sure we're following the SAD-MEG process. SAD-MEG stands for subtract, add, divide, multiply, exponents, and grouping. So we will always undo these operations while we're solving. So we'll undo any subtraction or addition that we find first, then any division or multiplication we see, then we undo exponents, and finally we'll undo anything left in grouping symbols. So here we have a basic two-step equation. We want to solve for n, meaning we want to isolate n and get it by itself. I like to draw a little line down my paper where my equal sign is to remind myself that anything that I need to get to the other side of that line, I'll need to undo its operation. So to isolate the n, I notice that I do have some subtraction here on the side with n. I need to undo that subtraction, meaning I need to add 9 to both sides. So negative 9 plus 9, that goes away. So we're just left with 5n equals negative 8. Lastly, we will divide both sides by 5, meaning n equals negative 8 fifths. I'm okay with you guys leaving your answers as simplified improper fractions. If you went and wrote it as a mixed number, it would be written as n equals negative 1 and 3/5. So either of these answers is acceptable. All right. Yep. Okay, so this one is fully solved out already. So I'll just walk you through how we would do this one, and then we'll look at some practice together. So equations with giant division bars, meaning we have a portion that has a big division sign in it. For equations like this, you need to get everything around that big division to the other side first. So isolate that entire division portion, and then we can solve for the variable that's left stuck in there. Think about big giant division as a grouping symbol of its own. Imagine they're a grouping symbol. So we would do this last. We would isolate that so that we could break it down at the end. So what I would need to do here first is actually add the 8 to both sides. So get the big division by itself. Once you have it by itself, so I add 8 to both sides, 5 plus 8 is 13, that's when I can then multiply both sides by 4 to undo this division. These cancel, and then I'm left with 2n minus 3 equals 13 times 4 is 52. At this point, I no longer have anything in fractions. I've isolated that big division, gotten rid of the division, and I'm now left with just that numerator, 2n minus 3. So finally, to get the n fully isolated, I can just add 3 to both sides and divide both sides by 2. Again, that improper simplified fraction is fine for your answer. So let's practice this. So here's an example very similar to the last one. We have something, an expression in the numerator of a big fraction here. So that means I'm going to get everything that's not in the fraction to the other side first, then I'll work to isolate the variable after that. So I'm going to subtract 7 from both sides to begin with, meaning this whole fraction just comes down and I recopy it as is. And negative 3 minus 7 is negative 10. So then from here, what we're going to do is now undo this division that we have. So I cannot break apart anything in this numerator. It is all locked together in that numerator. So the only thing that I'm allowed to do next is to get rid of this divide by 2. So I'm going to multiply both sides by 2. These will cancel out with each other, leaving us with 3n minus 5 and equal that to negative 20. Now that my entire numerator is completely out of the fraction, I can begin to unravel and get that n isolated. So add 5 to both sides, so 3n is equal to negative 15. And lastly, we will go ahead and divide both sides by 3. So n equals negative 5. Incidentally, if you want to check this, take negative 5, replace n with negative 5, and simplify. Make sure both sides are equal and you're good. So here's another one similar. We have this big fraction here. So I'm going to get the things outside of that fraction to the other side first. So this is a negative 3 plus everything, so I'm going to undo that negative 3 and add 3 to both sides, leaving us with 4n plus 1 over 2 equal to 9. Now we undo this dividing by 2 by multiplying both sides by 2. So 4n plus 1 equals 18. Subtract my 1. And divide both sides by 4. So n equals 17/4. Okay, so those are basic two-step equations and equations with giant division in them. Now let's look at equations with distribution. One thing that I will drill all year is that when you see distribution in an equation, you must distribute first. No matter what, we distribute first before we start solving, because this side of our equation is not simplified yet. So we have to simplify this side of our equation before we can isolate any variables. So distribute first, distribute first, distribute first. That means we need to distribute. So negative 6x minus 12 equals 12. Now that we've distributed, we can begin to isolate our x. So I will add 12 to both sides by undoing that subtraction, leaving us with negative 6x equals 24. And lastly, divide both sides by negative 6 to get x equals negative 4. So distribute first, distribute first. Now we're moving on to some basic word problems. So when you're reading your word problems, it's important that you break down the words that you're seeing that mean mathematical terms. So a medium orange has 70 calories. This is, and anytime I see that is, I circle it and put a big equal sign above that word, and I'd like for you to do the same. So this refers to the 70 calories. So 70 calories is 10 calories less than 1/4 of the calories in a sugar crunchy. How many calories are in a sugar crunchy? Ugh, I just got tongue twisted. In a sugar crunchy. Okay, so when we're doing word problems, I'm going to always expect several things from you. The first is that you define a variable. I'm going to use K, and I'm going to state that K stands for sugar crunchies. Okay, how many calories? Sorry, sugar crunchy calories. All right, so I'm going to be specific here and labeling that K stands for the calories in the sugar crunchies. Now that I've defined that variable, I'm going to be able to set up my equation. And it is incredibly important that the equation you set up is not simplified, meaning you are reading your numbers and words exactly as you see them in the sentence and just translating them to an equation. So let's reread. A medium orange has 70 calories. This 70 calories is means equals 10 calories less than. Well, less than we know means subtract, but if there's the word than after it, it also means to reverse the order that you're reading. So this 10 less than actually is not 10 minus, it's going to be whatever this is minus 10. So the less than and more than means flip the order. So let's break down this portion. 1/4, we know is the number 1/4, and of often means to multiply. So 1/4 of the calories in the sugar crunchy, which we just stated was K. So 1/4 K, now we do the minus 10. So that is our equation. 70 equals 1/4 K minus 10. That is 10 less than 1/4 the calories in the sugar crunchy. All right, so to solve this equation, I'm going to undo this minus 10 by adding 10 to both sides. And I'm left with 80 equals 1/4 k. So you could at this point divide both sides by 1/4, or a more natural way to do this is just multiply your equation through by your common denominator of 4. So 1/4 k times 4 and 4 times 80. So we should get 320 equals k. And lastly, let's state that there are 320 calories in a sugar crunchy. And now you've fully completed the word problem. Okay. All right. Our second word problem. A satellite repairman comes to John's house. He charged $50 for the home visit and $12 an hour to do the repair work. If the bill was, that's another fancy word for is, $98, how long did he work? So we need to figure out first, what are we looking for here? The question says, how long did he work? So let's set our variable, I'm going to call it x, to equal the hours he worked. And now we need to go about setting up our equation. So he charged $50 for the home visit and $12 an hour. Well, the $12 an hour means 12 times each hour that's worked. If he worked 2 hours, that's 24. 3 hours, it's 36. So it's a multiple of 12. So then we have to figure out, how do we combine the 12 and the 12, the 50 and the 12H? Well, the key word here is actually our and. If he works or is charging $50 just to show up, and then on top of that, the $12 an hour, this and really is addition. So we will set up 50 plus 12H, and that is equal to, this bill is, or the past tense is was, $98. So from here we now need to solve. So we will begin by subtracting 50 from both sides, getting 12H to equal 48. Divide both sides by 12, and H equals 4, meaning that he worked for 4 hours. So I will look for these key items from you in your word problem work, starting by identifying your variable, giving an unsimplified equation, you have not solved anything, showing your work to solve, and then your answer with units. All right, lastly, we're going to look at some special kinds of equation scenarios that can come up. So the first portion here is review. If an equation has distribution, it must be done first. If there are any variables or numbers that need to be simplified, it is done second. So finally, you solve the equation. So here we are. Now we not only have an expression that needs distribution, but it also has another x, which means we're going to have to combine those variables. So we're going to distribute first. So 2 times x is 2x. Minus 6. Remember, no matter what, distribute first, distribute first, distribute first. So we've done our distribution. Now we bring down the minus 5x equals 9. At this point, we can't isolate an x if there are several x's throughout our equation. So I'm now going to combine my like terms of x's. So I've got a 2x minus 5x. Well, that becomes negative 3x. So I have negative 3x minus 6 equals 9. Now I can solve this two-step equation. Negative 3x equals 15. Divide by negative 3. Oh no, my slide went away. Sorry. Negative 3, and x equals negative 5. Here are 2 more practice problems for you to try. I'll give you, why don't you pause the video, work through both of these, and then I'll come back and solve it. We'll solve it together. All right, so you've just paused the video. Now you can unpause it to check your work, and you can follow along with what I'm doing. So there's only one x. However, this 2 minus 9 needs to be simplified. Now I'll add my 7. Oops, sorry, that's a negative 6. So x should have equaled negative 3 there. Next, negative 4n plus distribute first, distribute first. And I need to combine these n's. So negative 4 plus 6 is 2n. Now I undo that subtraction. Divide by 2. N should equal 16. Make sure you had both of those. You can pause this and look at the work longer if you need to. All right, and finally, we're going to look at what happens when we have variables on both sides. So we'll always need to start by simplifying everything we can, distribute first if you see it. But when you notice, here we need to solve for n, we've got variables on both sides. So your first order of business actually is to combine those variables in some way. So to combine them, we are going to need to bring one of these to the other side of the equal sign. And when you cross over that equal sign line, you have to make sure you're undoing an operation. I'm going to bring my 2n to the right. However, you could bring the 5n to the left. It doesn't matter. We'll all get the same answer. Whatever you do, you need to undo its sign. So that means I need to subtract the 2n from both sides. And I get 4 equals 3n minus 8. Now that all my n's are in one place, I can undo all other operations and solve for n. So 4 equals n in this scenario. All right. There are 2 for you to practice here. We'll do that same thing. Pause, work them out, and come back together. Okay, so if you are finished, now let's check your work. Oops, minus 12. So for this one, you should have gotten negative 4 equals n. Oh, and I'll have to make this small. 2n plus 8. Distribute first. Combine your n. So I'm going to bring the 2n to the right and subtract it, giving me 3n minus 10 on that side. Add your 10. And I'm going to carry over here. Gives me 18 equals 3n. Divide by 3. And n equals 6. There are 2 more for you to try. Pause the video, complete these, then unpause to check. All right, so you are unpausing. Here we have some n's that can combine. I'm going to bring the 3n to the right. So I need to add it to undo its sign. That leaves me negative 8 on the left plus 8n. And this plus a negative 7, remember, can be written just as minus 7. So now to isolate this n, I need to get this minus 7 to the other side, so I add it, giving me negative 1 equals 8n, divide by 8, so n equals negative 1/8. Next problem, we have 2n minus a negative I don't like, so I'm going to write it as just plus. Combine your n's. 5 equals 2n plus 11. Now subtract that 11. Divide by 2 on both sides, n should equal 3. I'm sorry, negative 3, because of the negative over here. I just can't write it because my screen's not allowing me to. Okay, our final 2 scenarios are, one's going to be no solution equations and one's all real equations. So in this first scenario, if you begin and you're solving an equation and you're combining those variables and you notice that when you combine them, that goes away, so you're left with negative 6 equals, but 2n minus 2n is 0. This second set of variables also goes away. So if you notice that in your combining of variables, all of them go away, look at what's left and ask yourself, is this a true or false statement? Is negative 6 equal to 4? Well, hopefully you can see it's not. So this is a false equation, meaning that this is impossible to solve. There is no value for n that you can plug in that would make this equation true. You could try any number. You could try 1. If I put 1 in here, 2 times 1 plus 4 is 6. 2 times 1, 2. Minus 3 is negative. Sorry, minus negative 6 is negative 3. Oh my gosh, I can't talk. 2 minus 6 is negative 4. So those two sides are not equal. And so you could see and try that all day long looking for a value for n, but nothing will ever make it true. So n is equal to no solution, which you can write as a 0 with a slash through it. This is a false statement. And there's all of the work I just showed. Okay, so this is a false statement. There is no solution. The opposite can happen where if you notice you're combining your variables, and they both go away, but you're left with a true statement, then this means there are infinite solutions that could go in for n. So in this scenario, you would say that n is equal to the set of the reals. So that's a capital R with 2 lines. This is way too fancy. You don't have to write it like that, but this means there are infinite solutions that we could plug in for n, and they will make this equation true every single time. If you put 0 in for n, 3 equals 3. If you put 1 in for n, 8 equals 8. And we could do this all day long finding true values. So if the variables go away and your two numbers are equal, then, and it's true, then there are infinite solutions. So you say your variable is equal to the reals. And that sums up our very quick review of several different kinds of equations that you'll see solving. So you can now move on to practice.